I wouldn't doubt it, but so now you are understanding a little better and admitting that they're not going to take you to the very north to prove
There
there's
isn't any,
land or not land.
because
There's
that place
no
doesn't really
90.
exist.
Okay, I got you.
It's just
Fair enough.
the North Pole, celestial North Pole, is not really a point; it's a line.
Right. I'm just talking about geographic north.
Right, and I'm saying geographically, it's a line. Just the disk model projection wrapped it into a disk, where the North is not a line as it is, but it's a point.
Have you kept up with, like, over the years about magnetic point of north moving, like so
Yep.
many miles per year, and where it should be now? And if you think
It
about that,
migrated away
if
from
if the
basically
magnetic,
Norway to Greenland.
well,
moving
it's
towards
moving
Canada.
northwest, right?
It's moving
Northwest.
towards
I think.
Greenland, and like if it keeps going, then it'll be over Greenland, and then eventually it will go to Canada.
Oh, you're saying the magnetic point is east of Greenland? I thought it was on the other side already of Greenland.
It's on one side of Greenland. It's not in between Greenland and Canada
I
yet.
got you, brother. I got you. Yeah, it's pretty far. I mean, I don't know. I'm not the geologist that's studying all that. I'm just going off what I can see and read and stuff like that. Um, but yeah, it seems to be moving. And in that case, if it is, and let's just say the far right side of the ice wall, what we would flat earthers consider an ice wall, and if it's moving away from the far east wall and the magnetic point is speeding up and moving northwest, there is a growing belief now that certain parts of the ice wall would be refreezing as it moves, as the freezing point would be moving with the magnetic north, and then unfreezing, like thawing out, moving northwest. And that's why there's kind of a concerted effort to get these territories, and so certain coalitions or like UN or whoever, Americas and their allies, have control over that area to see what is thawing out. Like, at 33 degrees,
and that area is mostly
the
Russia.
Freemasonry or Freemason stuff starts thawing out. Does that make more sense? Like at 33 degrees, they make a big deal about it.
I don't know, probably, but I mean, it is literally moving, and Russia is thawing out. Like, it's becoming more hospitable compared to just completely frozen all year long.
Like Siberia area,
center.
Mhm.
Right, and that's why they want control of it, because it's like it's becoming available. Like, we want it. You're not allowed to have it. That's why they're getting greedy. That's why they're all piling on to go to war with Russia for whatever reason. Because they want to get the goodies now that it's thawing.
Well, if you were from the 80s and 90s, I always heard that the milkshake brings all the boys to the yard. Her milkshake. If you know what that means, it's a little coded message there.
I don't know. It sounds very American, like we're not into milkshakes.
Yeah, it's a joke. It's a song. Yeah.
Right, so there's a good chance that America and Canada and even Mexico are going to get colder. I mean, for Mexico, that could be a good thing, because it could become very moderate land, which will make it more fertile for crops and much more hospitable. And for the US, it could be problematic, because the northern states will kind of turn into Canada. And the southern state, everything for the south will be better. Like Texas is probably going to thrive massively in the next century. But I mean, Canada, there could be that parts of Canada are just going to get abandoned because it's going to get too cold.
I'm in a northern state in America. We're not going to turn into Canada, eh?
Right. I just mean climate-wise. Like, you're going to get Canada's traditional climate, while Canada actually kind of freezes over. Canada gets Greenland's climate. And Greenland could like freeze over even harder. But here's another interesting theory talking about the idea that magnetic pole shifting may actually determine how the climate regions are organized surrounding it. There's also like circles then probably around it that have moderate temperature, like in between the really cold region. Right? That's why there have been islands that are part of Norway that are incredibly far north, that are basically in between ices, but they are moderate climate. There's literally like grass growing there and everything. But it's surrounded by ice region. And so that kind of thing might also just start to happen in Greenland. That it gets hit, certain regions of it get hit by like a ring of moderate climate in between all the frozen stuff.
Yeah, you got a good point. What I've came to find out was that these deep currents versus these warmer surface currents, they they act very weird in the very north. In the very north, what they're showing us is like these toroidal type of movements with the currents. It's almost like a four-leaf clover kind of package. And you remember, I don't know if you all studied much about the ancient maps, but from the very center out, there are four heads, four rivers that are supposedly very strong, and they branch out in a total of 19, all in the four cardinal directions. And if you had underwater currents, some warm and some cold, deep and surface, and the patterns they're showing us make a lot of sense with the toroidal motion of the heavens, and pushing pressures down, and even the Mir space station video footage shows this kind of energy vortex. And they say as above, so below. So maybe the jet stream currents versus the underwater currents are two polarities turning simultaneously, right? In opposite directions.
In other words,
yeah, synchronized.
Synchronized, part of the magnetic vortex. Well, that I know very little about magnetics and vortexes. I'm not into that as much, but I know the feel and the typical patterns that reemerge with magnetics, and that makes absolute sense. So that would be the case, right? Because if there's going to be some magnetic center, it's going to have these fields surrounding it that will reach very far, and they're going to have their influences.
Yeah, and they move all through, from the north to the south and vice versa. It shows.
But in rings, though.
Well, no, this is kind of sporadic. But if you were to put the flat Earth projection map and try to sync up or translate the meaning of what they show us on a globe versus that, maybe it would unfold like equidistant from the center and be more how do you say it, uniform.
Yeah, it's complicated because with magnetics, you want the Earth to be a disk because then everything fits that typical pattern. But if it's rectangular looping, it might not be circle. Magnetics may simply work in straight lines, straight line fields on the larger scale. In the small scale, there will be circles, close proximity, right? But if it is a very large magnetic, it might then just line up in rectangles, actually, in lines, parallel lines, instead of circles. But that would be on a very fast, large scale. So
yeah, water definitely has a lot of conductivity. It's actually one of the best insulators you can find. But especially with the salinity, the thickness of the salt in certain areas vary. So yeah, maybe over those areas that it varies, it could play out totally different with static electricity in the air and so on and so forth. So a lot of forces,
magnetic
like you
fields
say,
are
on the large
different, though. Magnetic fields don't require conductivity, but it's rather secondary. Like magnetic fields can influence salt water, can bend it, give it direction. Not the other way around, though. It's not going to be, the conductivity has no relation to magnetics.
Sure.
Magnetic fields just
Sure.
go.
And I think that I think it comes from the firmament. You know, the oscillations would be a lot stronger there. Electromagnetism. I think with the crystalline structure, yeah, it should act different in the air versus the water. Yeah.
Well, there does seem to be this polarization from up there. You could call it the firmament and the Earth. So that's happening. Does it mean that it comes from this structure that's up there, or is it just rather the whole of it? Right? Like,
I don't know, but the temperature
is
varies very much. You know, with the coldness. I think personally, the Kármán line I think is a correlation of the gases and stuff up in the where the firmament would, if it is a dome shape, would coalesce to the point, like a curved point up there, an arch that wouldn't be like down here. You know, the temperatures are a whole lot warmer and it just behaves different, I think is what I'm trying to say up
right.
there.
It's where the weird super fluid cold sheet starts. That's weird and gives all these strange gases when you move in there. But I mean, that's not a firmament. It's just a super layer. It's what's above there. It becomes weird. But I mean, that's not the firmament though. That's just the uppermost regions.
Right. I'm not claiming that. I'm saying above that, like way above that would be where this electromagnetism, the most powerful point, right? Because the crystals, you know, how they oscillate, and the more pure, you know, I don't know how thick the firmament would be, but it seems like something would freeze up there at some point.
Well, it does. There is this
create
exchange. There's
solid.
a cold. But I mean, the cold is just there. There's no like magnetic central thing that's doing that. I mean, if that was the case, then you would go up and you wouldn't just have like this electrostatic potential difference. You would literally have a proximity to a magnetic field, because any device that's going to have an electric or magnetic influence is going to have fields that are centered around it that you will measure stronger when you get closer. So that's not there at all. There's no strong magnetic field that you're approaching as you're going upward. Unless I'm mistaken, but I've never heard of that, though. Have you? Right, but I mean, it could be explained differently too. It could be that it's so cold up there that the coldness basically kind of defies our Goldilocks zone type temperature workings. It could be that the material, when it's just super cold, just starts to function differently entirely, and that it is that cold might even be the cause of electrical and magnetic effects just by it being that cold. We don't know that over here because we don't experience that kind of cold in order to test whether that's the case. But we have things like super cooled magnets that are hyperfunctional. So there is a relation with magnetic strength and cold, right?
Yep, I'm listening. Sorry, I'm fixing some food here. Yeah, I mean, you also got to think of the you know, the potentiality of you know, quantum locking type of capabilities that we do see up there with the luminaries, right? It's almost like they're hanging in place, but they're stable. You know,
Yeah.
and some type of plasma or the
No.
or the electrified ionic, you know, kind of how do you say it? You know, excited gases, basically. I mean, I think that's all like one unit, and we're just seeing the results of it, right? I mean, we don't have to see the firmament to know it's there, right? As long as we see what it's producing at very cold temperatures, with
Yeah, but
what we know exists up there,
the
gases,
celestial lights are not
electricity.
part of that. Sorry. The celestial lights aren't that part
I
of that.
mean,
They're not super cold gas things or anything. Because if they were, then you would be able to approach them and get an actual close-up view and have angular size of them increase and notice.
well, do you think they would let you know
locationality.
that and show you that if they were?
But it isn't. It's exactly the
Because
opposite.
they only ever
They're
show you
just-
illustrations.
They're holograms. They're
TV.
no local holograms. They don't have actual positions. When you go up,
Right. Well,
Right.
oh, okay, but those are the lower ones, right? Like as you get higher, those still they don't change position other than the turnings, right?
Yeah, but they
but,
become dimmer.
Yeah, and I
They
do
become
have video
smaller.
footage of
The moon becomes
from
smaller. Everything becomes smaller. Like that means it's not in a location, because then perspective would apply, and it doesn't. It does the opposite of perspective. It's like you have to realize.
I mean, I
that
can
at
hear you
some
out.
point.
Yeah, I mean, I'm hearing you. I'm hearing you, and it could be a possibility, sure. You don't think they're like plasma in nature, though? Like that, I guess hologram
Nope.
could be a word used
No, it's just a
for
description.
excited gases.
No, but it isn't. It's not a piece of light it's a non-local hologram. They don't have actual positions. They don't have a fixed point.
Right.
It's like more like a hologram manifested throughout the realm with angular precision and consistency. But they're not like lights coming from a position anywhere. They're literally like holograms spread throughout the entire space as a background effect. But where they're coming from,
Right.
like nobody knows because you can't figure that out. It might be extra dimensionally. You could argue,
Yeah,
like,
yeah, I like that.
the
I
fifth
like that.
dimension.
Yeah, I like that. Because once you get up past the Kármán line, like, you know, we personally, with our own eyes or whatever, can't get to certain points. But I do have something I'd like you to see, just because we're speaking of it. But is in like 1994 or 1995, there was a satellite. I don't know where exactly it was, but all of these, you know, from looking from the bottom up, it just looks like if there's low light, like you can see billions of stars, right? It's what it looks like. Now, from where this satellite was looking across, they were trying to find the Mir space station, and it looked the same. There were billions of little points of light, and as they zoomed in, there was just more and more and more. And as they zoomed out, you know, it was a wider field again. So, but what do you think about that? If you've seen something like that, and it looked from a top view down, what it looked like from a bottom view up, what would you think of, or how would that influence your thoughts of it?
What the hell you mean top down? What does that mean?
Okay,
The
from a higher
celestial lights are
position.
always above eye level. There is no down.
If there was something that was placed up inside of this, all of these dots of light, and you could see down at the Earth, and it looked the same from top down as it does from the bottom up, right? You're having the same experience
That
of
makes no
points of light.
sense. I mean, that's
Oh.
highly fantastical.
Mhm.
That's already assuming that you're looking from a vantage point that's literally non-local holographic. So, I mean, how
Okay,
does
but
it look like?
you're not
We
giving it a
look at
chance.
that from our
You-
3D perspective type understanding of viewing. So, seems a futile action.
Okay. If they were a physical point, let's forget about the hologram.
Oh,
Could
okay.
you entertain that, like from that perspective?
I can imagine
From
having like a
if
scrying
you were at the
up
same
there.
height, let's say they were luminaries, you're in the middle of all these dots of light, right? And you're looking from a camera, and you move left and right, and you're just surrounded by these points of light. It looks the same as what I'm saying. From when you're down here looking up into that field, there's dots everywhere, but you're not in the middle of it. You're just looking from a different perspective.
I don't think
So
so.
if they were real
Wherever you
and they
are in
were
the realm, when you
physical,
look down, you don't see stars. Never.
man, bro, you're not listening. If you're way, way, way up there with them, if you were personally with them up there, and they were plasma living entities, and you did a 360, and they're everywhere around you, and you're looking down at the Earth.
Right. Just so you're standing in between a disc of light, roughly.
Kind of like between the sun, moon, and the Earth.
Yeah. Cool.
I'm gonna drop it just so you can see what I'm speaking of, and you can go from there. I just wanted to surprise you, man, because you seem like an intelligent guy that, you know, you may it may shock you. But let's put it that way.
I doubt it.
So, appreciate it. All right.
I'm not shocked
gonna
very
mute up so I can
quickly.
go get it.
Like
Gotcha.
any kind of idea or thought experiment based on the assumption that stars, sun, or moon are in actual locations is, for me, I'm just like, yeah, but it's not that. It's the same to me. Imagine that
Okay.
we're going to Mars and build a base there. It's like, yeah, that's really cool, but it's not actually real, though. You know, they're non-local holograms.
No, I'm not saying
Very
like
certain about it.
that. I'm not saying I don't. I mean they're in a soup of gases. Think of it like that, and they
I
are
know that you're
plasma,
thinking
so
of
they're
it like
not.
that, but it isn't, though.
So they don't have weight. Basically, they're very light. So and a toroidal motion could carry them in an orbit. Think of it like that.
Yeah, I know that type of imagination was like done by Rob Skiba and all that like 6-8 years ago. But it isn't that, though. 100% certain of it. It's amazing to think about it, but it isn't that, though. 100% certainty. It's just gases up there. That's it. And like going through it might have all kinds of weird effect and create plasma just by being there. But there's no persistent points that by themselves have any kind of influence over the celestial light that we get to see as the star, sun, and moon. That's all I'm saying. Something else is causing that. Anyway, I do appreciate the talk about this. So I'm just kind of trying to push my my view through. I'll take a look at whatever you're gonna share with me though in live stream text.
Yeah, no problem, no problem. I can hear you. I'm just on this other. Over on my X trying to find the post that I put over there. But yeah, I'm gonna drop it in the live text for sure.
Hello?
Hello?
Okay. Just checking in. How's everybody doing?
Doing pretty good here. It's been kind of quiet.
Nice. Did y'all take like a break or just not like there's no
Yeah,
topics?
I mean, I just had a bunch of conversations with guys, and I think they're just moving on.
I hear you. Sounds good.
And I just jumped in, so I have no idea what the convo is about.
You're good. I just
Hey,
hopped
yo.
in. Yeah, hey, I just hopped in. I was like just curious, like what's up? Because like I know usually like this server's pretty active, which is great. And like I don't know, like I just noticed y'all were in, so I was like, okay, let's see what's up, like what's going on. And then I noticed everybody was quiet, so I just
Yeah,
confirmed
it's been
like
kind of
everybody
quiet
was
for a
like
few days.
off.
So
Hmm?
it's been quiet for a few days. I think the guys
Oh,
get really active in the weekend, especially on Saturday and Friday. Usually, it's really like buzzing in here.
all right. Thanks for letting me know. I'll write that down so I don't forget it. Like know when to like hop in. Yeah. But yeah, I think that makes more sense though, because like weekends, like kind of like you're gonna have more time, especially like life and stuff. So yeah.
It's been quiet all around. It's been quiet on X as well.
Oh, yeah. Hey Arwin, I finally put it in there for you, the video. Hey Chris, it's RG. What's up?
Hi, RG.
Good to see you.
I'm sorry.
Yeah,
Did somebody say? I'm sorry if I cut you off. Did somebody say something prior before you did? Artist. Can I call you artist? Is that okay with you?
Sure. RG or artist? Yeah, sure.
Oh, RG. Okay. Did somebody say something prior before you said or afterwards? I think I heard somebody say something, but I wasn't.
Well, me and Arwin, I heard you when you came in. I was looking for this video. We were kind of discussing about the luminaries, and I think his stance was holographic and not physical at all. Like and I don't want to put words in his mouth, but I was just saying that
Non-local holographic angular manifestations.
Right.
I
And
have no idea what that is, but continue, please.
Well, for me, I think it's plasma in nature because there's a lot of gas up there in cold temperatures. And I was discussing that, when you're kind of at that elevation, if you put yourself way up there, like what they call satellites, what's up there, way, way up there in the upper atmospheres. And, in the Bible, it talks about, well, let's forget the Bible. What we see is this orbit around Polaris of these luminaries, right? Now, the video I just dropped in the chat there, it's back in the 90s, and what they're showing is some kind of view they put some kind of camera or something up there, and you can see that there's thousands and millions of points of light. And if you're down here on the ground looking up, you kind of see the same thing. But it's weird because as you go up, like 100,000 feet, they start to disappear, right? And I think that's why, Arwijn, is that right, where you get your stance on why they're holographic? Because they do that kind of thing.
It's not
Yeah, but if you
exclusively. I get what
I'm
you mean.
s-
It's not exclusively based on that particular thing, but it is a contributing factor. Now, it's
yeah,
just that they're not lights in actual positions. You can't approach them and see the angular size of the light source grow, which any object that is a light source would do if it was provably a physical light source. Any light source that grows because you move towards it, because you know where it is. If you want to be able to see it very far away, it has to be big up close. And there's no
yeah,
experience of that happening with any of the celestial light. They
yeah.
stay
That's what.
at a fixed apparent distance at all times, and on top of that, disappear when you go up high
Yeah,
enough.
but if you look at our world, everything is lying in the water. And if you look at the sky above us, that is water vapor in that. And that is a perfect reflector, a perfect mirror, basically. And if you look at everything, it emits electromagnetic radiation. I always tell people the heavens show us at his handiwork. So the heavens show us just all the electromagnetic radiations of the waters below, of all the lands in the waters.
Okay, that still doesn't give a physical explanation of what they are, but yeah, it is interesting.
I think it's more reflection of electromagnetic radiation. Because if you look at magnetic hysteresis, that is the drag of the light of an object behind the object itself. And if you look at that 15-degree shift we see per hour, that could be a little drag of the whole system. Because if you have a rotating system, when you have a really slow rotation at the center, at the border of that system, that rotation will be a lot faster. And even if you look at the tectonic plates, we have the North American tectonic plates making an anti-clockwise turning, while the Eurasian plates makes a slight clockwise turning. It's just a few centimeters a year. But if you look at how everything moves in the sky, it doesn't move very fast. It takes 24 hours to pass us, only half. So
Yeah,
I think it's just, yeah.
but they're not connected though location-wise, which is not. Celestial lights don't have actual position. They have angular apparent positions.
Yeah, it's an apparent position because it's not, because we have reflection and we have refraction. We have it both ways.
It's coming from somewhere, no doubt, but it can't be reflected, and there is a pathway. Reflection only applies to actual positions. Otherwise, yeah, you can reflect it in the mirror. You could take a look at the sun in the mirror and then see it, but you can't like go towards the sun and then try to trace back the original position on Earth from which it is being reflected, like, because it's not literally a mirror. Mirrors have very specific ways.
Yeah, but I'm not talking about the sun. I'm talking about the stars.
Can I ask?
Maybe the sun is also part of that.
Can I just interrupt?
Yeah, but
quickly?
the sun is something different.
Can you hear me?
Yes,
I just meant to
Yeah,
interrupt. Okay. So full disclaimer, I still don't know what y'all are talking about. I do still appreciate you sharing the information back and forth, even if I don't know what y'all are talking about. But I'm just feel like letting know that I'm gonna have to go now. But thank you still. I don't know, was it like Arwijn or artist?
Yeah,
I forgot
Arwijn.
who it was who mentioned about the server thing. I wrote it down, so I look forward to that. Maybe next time we can like talk about some other topics like Friday or stuff. So yeah.
All right.
But hey, it was nice chatting with
Cool,
y'all. Appreciate the info.
Yeah, you too.
And yeah, take care. Bye.
Awesome. You too.
See you around.
See ya.
Hey, Arwijn, I did want to mention when you said just earlier that if it was something physical or had a physical location, that it would get bigger as your perspective. It wouldn't stay just one size, right? And you said it does stay one size, but I would like to challenge that, just because when you're on the ground, let's just say with the P1000 Nikon,
Are you playing music?
and you zoom
Too
and
loud.
yeah, okay, and if you zoom in on the stars, that
Right.
the star will get a whole lot bigger in your screen, which means you can get closer to it if it is in a stable place.
I don't know what you're talking about, but I mean, it's not angular size increase.
Yeah, you can make the angular size increase with just a camera. It could go from a very tiny speck to filling your whole screen, which means if you approach that
that's-
one little spot, it could get bigger and bigger and bigger as you got
No, but
closer to it.
there's no demonstration of that actually happening. You can expose the
A
camera
camera.
longer and
A
then
camera.
get more depth and everything, but no, I've
It
not
just
seen
makes
any
sense.
evidence.
Camera. Okay.
I'd love to see a demonstration of that, but I've never heard of somebody going up there and then seeing the angular size of a celestial light steadily increase. I've never heard of that. Right? There's actually
Well-
like a uniform effect where it seems the closer down to Earth, they say the atmosphere magnifies the celestial lights. And
Yeah,
even
but
if the
that's
air is very
bullshit.
thick, that it magnifies it even further.
When
But
I'm driving in the
and it
Netherlands,
shouldn't happen up there because there is no thick atmosphere up there. So it should never happen. Even logically consistent wise, it should never happen.
yeah, but how come when I'm driving on the roundabout of my city, when the sun is coming up in the morning, and that sun is huge, and when I drive closer to it, it keeps on getting huge. But when it goes in the afternoon, when it rises higher up in the sky, it gets smaller and smaller. That means it is in the morning, it's closer to me, and in the afternoon, it's farther away from me.
No, but it isn't though. That's just appearances. It's lensing through. It's lensing through the atmosphere. The non-local hologram seems bigger when you're looking through thicker medium. It's weird, but
Yeah,
that's
but
what
that's
it
the
does.
same with the moon. When you're driving around with it, things change size and position all around you.
Yeah, but not consistent with perspective though. It's more consistent
Well,
with
and it's cold where she
with,
lives.
with the
Like
angle.
it
You're
shouldn't
looking
have as
through
much.
how thick the atmosphere is in that angle. If you look horizontal, you're looking through the thickest layer of air on Earth.
Mhm.
And that
Well, I mean,
seems
I
to
get that,
cause
but
the
when it's hot,
magnification.
Yeah,
it
but
does
that's only
magnify
when
when
it's
it's hotter.
15. That's only when it's below 15 degrees. When it's above 15 degrees, that doesn't count anymore.
No, it does count. It like that is persistent.
The military doesn't account for refraction lower than below 15 degrees of the horizon. So
Yeah, but
that's
that's
bullshit.
that's angular position alteration. I'm talking about magnification, not refraction, not angle change, overall sizing up.
Yeah,
You
but
know,
when
that-
you're moving around, the angle is always changing.
Yes, but look, refraction is the alteration of an angle because of a medium refracting effect. Like that changes the angle, right? Like you're looking through a glass with water in it, it's going to change the angle of the light passing through it. That's a refraction.
Well, we get
That's
we
not
get
Yeah, but
happening.
what I'm
we get that.
saying to you
What
is when I'm
saying
on
is
the move,
magnification. If
that
you're looking
thing
through a
keeps
thicker
changing
medium, it's going
size,
to magnify. Specifically that.
depending on the direction that I'm driving away from it towards it of sideways. That moon's moon size will change because the angle of perception is different.
Right, and I'm telling you, that is correct. And when it comes to the horizon, it will seem bigger when it's coming from there or when it's going away. And in certain unique circumstances, when it's very dry and you're kind of high up, you can even like see the sun like turn very little. And it will seem like it speeds off because the angular speed is still consistent, but it's getting magnified or shrunken at the horizon, depending on the circumstances there in the distance. And mostly it just gets magnified.
I think she mentioned when it's high in the sky as well, not even close to the horizon, that it's still changed for her from her perspective. And also, I just wanted to mention
Yep.
elevation in
It gets
planes.
smaller.
I've seen. Hold on one second. In planes, I have seen the same thing that she's mentioning. When you're above, like the thickest part of the atmosphere, there's still less lensing and more. It seems that things are getting closer, then further away, it is bigger and smaller.
But the light gets more intense, but the angular side of the apparent disk does get smaller when it's above because it's lensing less. Because of the total apparent distance in that direction, there's less atmospheric pressure up there, which decreases the overall lensing of the apparent holographic.
I got you. I just think be a little more open if you would, instead of having just one like holographic mindset. It could be that things were created and put up there outside of technology. Could be living technology.
Sure, but I mean, I'm just talking about physical consistency, and when you can't establish an actual position or see angular size increase when you physically are trying to approach it, and other things occur, then got to come to the conclusion can't be proven to be a light source, that it is in a specific position in Euclidean space, because then it would
Mhm.
abide by the laws of perspective, which it absolutely does not.
Oh,
at
I-
any
we
point.
agree
Gotcha.
about that.
Um,
I'm totally agree with you that ain't the physical object we are looking at.
Yeah, check out the
Right, and that's why I
check
call
out
it a
the
hologram, because that, for me, that's the only alternative to even move towards in order to try
right.
to explain the observation. I have no alternative left other than to just call it something mystical and be very confusing and not configurable for a scientific approach, which I really want to
Yeah.
do.
Well, sometimes that's the problem with science is it doesn't include the metaphysical. But yeah, check out that video. I'm not here to clash heads or nothing. I just wanted you to see that because from that perspective, with that camera zooming in and out, it's as if you can go through, like you're traveling through this huge field of lights, and that you can go through them if you are up there. Like you could travel through them, and they could be behind
Yeah,
you or in
I've
front of
seen.
you.
Yeah,
Yeah,
you're
but
showing
But yeah,
you
just
yourself.
made
check it out.
You're
you
showing
made a good
yourself.
point about those gases, because it always amazed me when if you have like a neon, when you put the oxygen with it, it gets a blue color, and it's with all the gases. It gets an orange color. I mean, not a blue color. But if you look at all the gases when they come into contact with oxygen and the color they provide, and you look at the sun in our sky with the whole coloring that is going around it, it must be something. Must have something to do with gases.
Well, gases are certainly going to influence light. Light going through gases influence the light. I mean, we
Yeah,
have
but that
different colored light bulbs
that
because
oxygen is essential to get that color.
well, oxygen is a part of the air. So, but I mean, if you like put a lamp in a
But then
box
it can be in
and
vacuum
you fill the
space.
box with a different type of gas, completely different, like all the lights and how it looks will become different because the type of gas will determine like the light communication as well, like how the light will be transferred. It is affected by the gas through which it is going.
Yeah, but then the whole theory, because those colors need oxygen, and they say there is no oxygen in space. Well, that's what NASA's telling us. Then you know by origin, basically, that the whole fucking thing is bullshit.
Yeah, but I mean, second law of thermodynamics, we're living in a closed system, like all that. I'm much more interested in actually figure out what is actually going on. Because seems to be a lot more complicated. I really think that the globe and all that was actually invented just to satisfy a certain layer of intelligence with people, like people that are smart enough to be able to absorb a whole bunch of facts, but not smart enough to see that it's actually missing a whole bunch of things, right? People that insist on having a whole worldview without necessarily a critical thought, because to actually figure out, to actually give a model of the real thing is probably so freaking complicated and
Yeah.
problematic that just nobody out there would typically be able to actually start to understand it. So to give out the full cosmology of how it actually works would probably make everybody just feel stupid. And I think that's part of the reason why they did the globe model. So that they could basically feed a consistent illusion that at least made a whole category of people that are really good at memorizing things and facts and details and the math. It would make them feel smart about themselves because they were
Yeah, and
thinking they were mastering reality. I
they
think that may
base
be
the
part
whole
of it.
thing on a circle. That's just it. Because they always say, if you look at the globe mat, it is all based on a circle. But if you look at the ancients, their mat, they only knew of a circle, a triangle, and a square, and a sphere, which is a half of a ball, a hollow ball, the sky above the ground, basically. And that's just 180-degree half of a circle, basically. So if you look at that, and if you look at, and before the 19th century, everything, all in physics was based on elements suspended in liquids or gases. And that comes pretty close to what we see in our world, because I always say, look at a bubble in water. That water, and then if you look at creation story, God separated the waters from above and below. And if you look at, even when you blow with the soap bubbles and you blow a soap bell, I think it's more like that. And everything floats in it, basically, because everything is water and water vapor, and everything is a non-equilibrium, and we find some kind of equilibrium in the midst of in that system. And I think it's the geometry of all the solids in the water that make up together the geometry and the magnetic field together with the waters and the sky. It's all together. And everybody's always focusing on the ether, but if you look at the vacuum, if you put a bell into it, that sound won't propagate. When you pull all the elements out of it, there's still light propagating into that thing. And then I go back to that thing of Gerard Pollack with the separation of discharge and charge, where there was a shell of discharge surrounding on all water relating surfaces, basically. And then it just clicks.
Yeah.
Because that charge, that is basically, and if you look at the hydrodynamics of the waters, even our oceans have a flow from both of those continents. They have a flow in the center that comes together, that makes up the hydrodynamics of the whole system. It's beautiful, it's simple, basically, but it's a really beautiful system.
Yeah, we were just talking about the currents not too long ago, the deep currents and the more surface currents. And if you put it on a projection of, a flat Earth projection map, it would be like a 1-for-1 match of the jet streams and wind currents above the water. It's almost like two opposite polarity rotating fields below the water and above the water. That's what I was thinking.
Yeah, but even Walter Russell talks about it with the negative and the positive. And yeah, I always get them messed up. I need to get the book by it to say it right. But it has to do with the magnetic is a centrifugal, and the dielectric is centripetal. And it's like two vortexes, but it's like a swirling that those swirlings you could turn on a stick, you could turn around. When you start swirling them, it looks like it's going up and down at the same time. And it's just like we see with our stars. We have that's star parallax. From one side of the stars is going one side, and the others are going the other side. And that is basically, it looks like it is two rotations coming together at the central point. And if you look at our zodiac, basically ain't that old. And if you look at those star signs, we have basically two star rotations that are joined into one, but they don't turn in the same size, but they follow the same direction as the tectonic plates do. So that's why I think the lands below and electromagnetic radiation with the sky above, it's connected. It's an interaction of the two. And I think the sky just magnifies that radiation until it hits basically the outer shell, the negative charge, ionosphere, like they say. But that doesn't make our world a ball. That makes our world surrounded by a sphere.
Yeah, the good old celestial sphere. And the symbolism that's been passed down for so long of the golden mean, the golden spiral. In my opinion, I think it starts with Polaris, and it goes around and down. It travels up and down the what we would call the shape of a dome, right, or the magnetic field, and it oscillates up and down, and that's where we get the path of the sun and moon sine waves. That's what I think. Yeah.
Yeah, but I think that everything in our world oscillates. It's not that everything is spinning. It's oscillating. Even our oceans show you that. We have a movement going from east to west and back. That's a harmonic motion, basically. But there is a boundary. Our oceans show that, because if there wasn't a boundary, then we'd be going in one direction for all times. So that alone tells you we ain't spinning in one direction.
Yeah, this is a good conversation. I'm kind of eating, that's why I'm not talking so much. But yeah, thank you for being here, Chris. And Arwijn, what do you think about some of this? What she's mentioning?
It's kind of out of my reach. I mean, there's a whole bunch of things going on out there physically, magnetically, electrically. But I think that with that, people that are into that do tend to eventually develop like a Euclidean disk view of what the realm is, in order to favor these kinds of effects that are field based. And so I tend to be naturally skeptical and suspicious of that kind of reasoning in general, because it always leads to disk thinking. And I think that's categorically incorrect.
Yeah, but it's not a disk, because if you look at how the lands are built up in height, we have the Gobekli Tepe area, that is basically the lowest area in our world, while Antarctica is the highest land in our world. So it's not flat. So we know it has level in it. So it's not a flat plane.
That's a topographical straw man. Yeah, the flat is not about the topography of the Earth. It's about the geometric orientation of the surface and level. And it's flat. It is, in that sense, very much flat, just because there are plateaus that are much higher, or walls or mountains.
Yeah, but
Does
that's
not
the
make it not
base.
flat.
That's the base, but it means that
The
your
orientation.
world is coming from a lower area going up to a higher area. That's what I mean. So it can all be flat planes, but they are not in one height. If you get what I mean.
Right, but I mean that's a topographical matter. They're all parallel. They're all levels parallel everywhere, and that's what the Earth being flat is about.
I don't see the problem with the description. Why do you call it a straw man if we talk about a topographical plane?
No, it's just that when this is something that Bev comes around in the chat every so often, also says the Earth is not flat because you're having topography. There's mountains and there's things, but that's not what the Earth being flat is about. It's about level
It's
being
about
parallel
baseline.
everywhere.
It's about the baseline in between, and that is
Yeah.
flat.
It's a geometric orientation of water at rest, basically.
Yeah, but that's why they always a discussion about what is sea level. And then I always say, look at the shores, look at the bottom of the ocean, and take the line in the middle of in the between. And take the line in between that. That is basically your sea level. So all the discussion about the time gauges and all that bullshit is bullshit because we know the depth of the sea, we know the height of the land. We can sure as hell find a middle ground in that knot.
Here. I second that.
Right. That's the same reason as saying like, oh, this table is not perfectly flat. Why? Because when I zoom in with it with a microscope, you can see that the surface is like all jagged and there's holes in there and it's not really perfectly even. And so you can argue that there's no table in existence that is actually flat.
Yeah, but that's a discussion without an end.
Yeah, and that's what Bev does. He's been doing that for like 8 years now.
He can keep it up.
Oh, he never stops. If you let him, he'll like talk about that for like 6 hours until everybody has a head.
Yeah, everybody keeps talking about the same shit, perspective and vanishing point. If you don't get that by now, then you're really hopeless.
Indeed, but I mean, it is kind of difficult to understand optics for a lot of people, right? When we're learning geometry and shapes and
Haven't they had a
cues
drawing class
before
in
we
high
actually
school?
learn about optics. Most people don't even get any optics in school at all at physics.
Right.
Yeah. But in the first
Because
and
it's really
second
difficult.
grade, you get drawing classes with the perspective and everything I had in high school.
Yeah, me too.
Yeah, but that's not the
You
same.
know, and this is why this is a good reason why that flat earthers that have been in it for a while are great teachers for the next generation because I mean, hands down, we've got way above college, what they would call authority, appeal to authority. Like, bro, we've got them whooped like by many times. Yeah.
Yeah, but when we keep talking, like with the Michelson-Morley experiment, they keep telling us, oh, there's no motion. But the really important thing about that experiment, everybody passes by that null result they really measured. Because even after the corrections they do, that still keeps you with 1 or 2 kilometers a second, the measurement that is left over. And I asked Rock about it. And then I asked it about the electromagnetic radiation of the Earth, about the P waves and S waves. And wonder by wonder, it is almost exact the same as a leftover of that null result of Michelson-Morley experiment. So, and everybody keeps jumping from, oh, it's about, no, you should jump on that piece because that piece really shows you what they are really measuring.
What are they measuring?
If there's, you know what? If you have a world that's in vibration, everything vibrates. Even the Schumann resonance proves that we have a middle frequency, a higher frequency, and one below that. That shows you that everything is vibration. That is movement. And movement, any way you turn it, that will always make sure that you're not staying on the same spots forever. So
Well,
that basically tells you, and if electromagnetic radiation is something you can measure. And the thing they measured is P waves, and it comes from tectonic movement of something from movement that is coming out of our Earth.
Mm-hmm.
not entirely what that is, but I mean, Schumann resonance, it's not about everything is vibrating, about everything
Everything is
has a
oscillating.
frequency when vibration is introduced, right? It's
Yeah,
about
but
the
everything.
resonance, like when
what
is
you
something going to vibrate with it on what specific frequency. Doesn't mean
But-
that everything is always vibrating.
Yeah, but everything that is on the move will set off a
specific
vibration, and that vibration will be interacting with everything in the surrounding, and will set off their vibration. So basically, in principle, everything is moving because you're in the closed system, and everything is interacting with each other.
What do you mean a closed system? Are you talking about in the
Oh
experiment?
my God.
Sorry, I didn't mean to speak over you, man. Go ahead. My bad.
I'm just saying it doesn't mean everything is vibrating. Everything has a vibration frequency that makes it resonate. So everything is resonating vibrations of its frequency when they are around. Then it
And
will
that is
make things
motion.
resonate. And it doesn't mean that everything is always vibrating.
So this experiment that you're talking about, you said Michelson-Morley, right?
Yeah.
Yeah.
Michelson.
Is that kind of like? Did they use like a larger scale of like what the ring gyro is? Is it like lasers bouncing off a mirror, or is this a different one?
It's an
It's similar to
engineering
that. It's
test and a
flipped.
man-made device. It's not scientifically legitimate.
Oh,
It has
It's
to
a
do-
motion.
it has
They
to
have
do
the
just with
It was
light.
people in
repeated
motion.
multiple times, so it's definitely scientific.
No, not by the strictest sense of the word. Independent variable is actually an effect that is directly caused by a man-made device that doesn't take place in nature.
so do y'all think that it is the ether or whatever? What do you call it? What did Bob, whenever he did the ring gyro thing, didn't they say that it's the ether is rotating like
That's
moving?
what they said, but I mean that's a presupposition that there is an ether to rotate. And gyroscopes don't drift
come on,
because when
man.
they drift, they're
Well,
broken. He bought
okay,
a
well, one more
broken gyroscope.
one more question then, because I heard Ken Wheeler say one time that you can take two neodymium magnets, drill holes in them, and then flip the polarity, squeeze them real tight using a butterfly, screw butterfly washer on a butterfly nut on a screw, right? Squeeze them tight, and then you grab it, and then you go real quickly. And he claims that it's all of a sudden slows down like your hands going through thick honey, and then if you move it towards the ground, it does the same thing. And he says that proves that, according to what science understands about magnetism, that they can't explain it because he says that it's interacting with the ether. What do y'all think?
That sounds like complete nonsense. But I mean, I'm sure there are tons of effects that happen. All right. And what
Well,
no, but let me explain something. Like
yeah, go ahead.
something that's
Guys,
really
I need to go. See you later.
See you
Bye
later.
bye.
All right, Mr. Have a good day, hon.
Go ahead, Arwijn. I'll listen.
Right. There's something that is universal about all people that think about things, try to figure them out, right? Physicists, free thinkers, flat earthers, like they all have a thing in common. And that is whatever it is that is the hot new item that everybody wants to hear about or everybody likes to figure out what it is, that's always going to be the go-to to explain absolutely everything, especially new, unique little phenomenon that you find in man-made devices. And there is tons of unique effects in electrics and magnetics that happen.
Yeah.
And then it's just like, oh, look, it's happening. Why? Because of the ether. Yeah. Well, 100 years ago, it's like, oh, look, this is happening. Why? Wow, because of gravity.
Well,
That was the hot thing. So everything would be caused by gravity in some way, and everybody wanted to mathematically prove that it's caused by gravity because it was the hot item. Now the hot item is ether, and now all the people want to prove that whatever thing they're finding is caused by ether, and they use math to do that.
Well,
so
let me get
why people do that.
Let me get your opinion then. So I play with magnets, but I haven't bought the magnets, and Ken Wheeler's like, anybody can do this. It's really simple. Just do it, but be careful. So it seems like you have to move faster than free fall. So you have to move up quickly and then down quickly. So what about magnets? What do you think is stopping your hand from wanting to move quickly towards the ground? Like, what is that? What are those magnets interacting with just in the air while you have this bolt with the magnets on it moving up and down quickly? What's your opinion?
Fields. I mean, fields probably have some kind of weird polarity thing. Like when there's magnetic fields, there's polarity things.
Okay.
And
So pretty much it could be Earth's magnetic field that's just interacting with it?
Just the magnet. There's
But I
two
mean-
magnets involved, right? You're talking
Right.
about something doing a test with two magnets?
Yeah, but it has to be at a certain rate. So you have to throw it down or have it in your hand. He says that it's best, he explains do it in your hand, move up real quickly, and you feel a force like slowing your hand down.
Right. So you're basically, let me try to describe it, talking about an apparent magnetic inertia.
Well, is that
I think
am I correct?
you're magnifying the effect of the field by, putting the polarities against each other.
Right.
So yeah, it's going to feel thicker. Like there is a medium. Let's not use the ether word because
Okay.
the
There's an
ether was
inertia
taken
effect
off
then.
of the ether was taken off of the scientific what do you call it? Back in the like 1800s, there's the
Right.
all the elements, right? And the ether was one of them, and everyone knew that there was a background medium that you could interact with. These fields do come out of that.
Okay.
And I don't want to say ether, but yeah, definitely you can toy with the amplifications or the weakening of the fields. Yeah,
Would you
for
would you
sure.
agree then that would you agree that once you create when you put the magnets and push them together really hard like that, and they're trying to push apart, so you're creating a field effect, but when you move them quickly, is it now interacting with the fields around the fields like trying to push a ball through water? You know what I mean? Like you can
Okay,
move a ball.
that's a
You know what I mean?
good question. It's a good question. So like if you there's something called magnetic bowl arrays. If you want to write that down, I've got the free open source patents for them. But they're neodymium magnets that are all northern in one bowl and then all placed with southern polarities in another. And they're like shaped in the shape of what we would call a dome or a firmament. And if you point these, what it's doing is it's spinning. It's creating a toroidal field that shoots out of it. One's northern, like I say, and then if you line those up perfectly, the southern and northern polarities meet at a very strong toroidal twisting motion, and right where you can't see it, but it's the fields aimed right at each other. And when they meet, it'll and I mean this with all if you guys are all sciencey and everything's got to be science. But anyway, what it does is it'll rip open a spot in that field, which is called the ether
Okay.
to me. And
Yeah.
what it'll
It's
do
actually engineering.
if you hit it with some gas and
Yeah.
electrical current, you just create this spark. You'll create plasma, and that toroidal motion will leave that plasma coming out of the ether. Basically, it's a 0 point energy that you're just torn open in the
Man,
medium.
you're giving me flashbacks of all the years I listened to Eric Dollard. That's kind of like the stuff he was explaining, and it was a little over my head, but you're making it sound a little more.
Yeah,
Yeah,
I'll post something here in the chat, and you can see it for your own eyes. Like it's
So
beautiful.
that is interesting. But I mean,
Well,
it
you
is
know,
basically just
Yep.
magnetics and it pulling on everything. Like magnetics can literally tear material apart in circumstance. Magnetic fields are pliable and will adapt to whatever other magnetic fields are also present. So magnetic fields can change shape depending on other magnetic influence. Right? It's a very malleable thing.
yeah, man, I really want to. Now I want to buy
And
those
it's
magnets.
all of this is in the field of engineering. It threads way outside of science. I
Well,
mean, they still call it science because, of course, right? But it's engineering, though. Like none of this
Well,
occurs in nature.
if you can do these kind of experiments, and it's repetitive with the same results, that's what's genius and beautiful about it. I'll be back though. I'll probably be on mute for a
Absolutely.
second, but I'm going to put it in the live chat for everyone.
I'm looking at something somebody just posted in the chat. New world model here. Well, Arwyn.
Yeah.
I'm gonna get one more opinion, then I got to run to my little girl's school for a little band thing. But
Okay.
yeah. So I did this thing one time. This was a while back when I was watching what's the Rob Skiba, right? He was using that lens, to kind of do like an experiment of how light works using
Yeah,
the
the dome lens trying to emulate the celestial lights with a glass dome and all that. I know.
yeah. Well, this
They
was
all did that.
he was using that reading paper that's a lens. You know what I mean? That floppy paper or the floppy
Yeah.
plastic.
No, I totally get it. Yeah.
Well, one time I'm like, okay, well, if light, if not, what do you call it, Eric Dollard and Ken Wheeler's right, and it is pressure mediation or whatever. And I talked to Whitsitt about it. I was trying to figure it out. Well, I'm like, wait a second, okay, if it acts kind of like fluid dynamics, the way waves work, and how you can have pressure in a wave, and then you can create a bottle point, and you may barely see a ripple on the top of the water, but there is pressure traveling underwater while you're seeing cross waves going across each other, still being able to travel. Then we could call it refraction, but we could also call it bouncing off of other waves. So I'm thinking, okay, well, if light can be brought to a bottleneck by using a lens, could I write a message on a light bulb with a permanent marker, right? Like an incandescent light bulb, then walk about 40, 50 feet away, and then use that lens to bring the light to really, squeeze it together as if it's like being bottlenecked, brought back,
Yeah.
and that message pop up on the fence, and I did it. I'm like, wow, it's crazy how the information is still there. It's traveling. It's being refracted, but still it's there.
It's called hologrammatic.
Yeah.
Light is hologrammatic in nature, and that's how photography works, right? You have a
Yeah.
little hole in the big black box, and then through that hole, the visual of the whole that is all in the distance goes through that one little hole and then projects itself once again hologrammatic, and that's why photography exists.
Yeah, but what's weird is like with a as we know with a camera, right? It's capturing light that's bouncing off objects and coming, unless it's less like a flashlight coming at the lens. So I'm like, how
theoretically that's how they say that it goes, the bouncing.
Yeah, but I'm like, how in the world does the light travel through the light bulb, through the magic marker that you know what I mean? But yet it comes through on the other side, crystal clear, sharp, 50 feet away on the fence, when it's just a it's not a very bright light bulb. You know what I mean? Like, it's just weird that the information's still there, even though it's diverging out. It's just crazy.
It's only weird if you,
Interesting.
as a base assumption, think that light has a minimum size, like a particle. But once you start to realize that that's not actually the case, and that was only assumed in the knowing which path experiment for convenience of thinking of it as a particle mathematically, and you realize that it's actually an infinitely divisible instantaneous beam unit, then if you realize it is infinitely divisible, then that effect of hologrammatic nature is completely understandable, because light can always split up indefinitely and then return to full size again.
You're speaking way over my head, but I'll be back, man. I appreciate it.
It's the light. I think he was always trying to say it's always ever present. It's not really traveling. It just propagates out of the background medium.
No, it's
Now,
instant.
and let me say this real quick.
literally instantaneous.
The bottlenecking. Hold on one second. When you said bottlenecking, I placed 3 videos in the chat when you get ready for them. But bottlenecking, the opposite polarities of electromagnetic spinning, it's a toroidal, and you point them right at each other where they meet. It will, like I say, it will tear open like almost like a 0-point energy spot, and it exposes the light back in the background medium. And all it does is opens up a little spot, but it has to be opposite spinning toroidal, opposite polarities. You'll see.
Okay.
In the videos.
Well, I'm looking for the live stream chat here, and I don't see you. The last thing that's posted says it's a video called "The New World Model." Am I on the wrong thing here? Oh, wait a second. Yeah, I'm in the wrong thing.
Yeah.
The light doesn't come through the hole. The light bounces off the edges of the circle of the hole and gathers into one point.
Okay. Yeah, I have a lot of them too. I just know what.
Does that make sense?
Yes, it actually does. Because of the spiraling, and it creates that circle, like almost like a sphere. I mean, in a way, you think like a bubble or something, right? Something like that.
That's why diaphragma works, right? When you make it smaller, it creates a smaller point. The bigger the bigger the hole is, the more difficult it is to get it sharp at opposing wall.
Yes. And the cool thing about these magnetic Bowl arrays is that there's a lot of strong neodymium magnets, which speeds up the turning, the toroidal effect. And I mean, just the outlet where these two meet, I mean, it's just so powerful that you hit it with one little spark of electricity. That's all it needs, and it's permanent plasma. Then it's pretty cool. And no moving parts. Only just the placement of the magnets are geometrically symmetrical. And the bigger the magnetic Bowl array, the more powerful you're going to get. Yeah.
Sounds interesting. I mean, sounds to me like trapping plasma with like perfected magnetic fields. That's how that works. There's plasma.
That's a good way to put it. Yeah. And it's
right. When there's plasma, there's always going to be magnets involved.
Oh yeah.
Because
that's why when we were talking about the stars earlier, right? And that's kind of why we were talking about and this is a miniature version of, let's say, the firmament we were talking about earlier. Well, these magnetic bowl shapes, they're patented, they're free, open source, and you can make them yourself. And it's just a small scale of what, like, we can't see it with our spectrum, but the magnets, the power it's putting out. When you add hydrogen and boron together, you see the luminaries all of a sudden, like what would be a holographic luminary, like you were saying earlier. It's the same. It's just on a different spectrum that the effects are happening, right?
I'd like to see a demonstration. That never heard of that. That's the first time.
Yes, sir. I'm on. I dropped 3 videos already, but then if you go to David Lapointe, Lapointe, David Lapointe, he's got instead of the primer fields, it's primer fusion reaction, and it's got this hydrogen boron, still the same magnetic Bowl array patent, still the same thing, but very powerful. You could run a house for a year for $10 of boron. That's no lie. And I know how to build the machines. Yeah, and so does he. It's about the size of a refrigerator.
What? That's nuts.
Boron's the metal that causes water to do electrolysis, or what? What are you doing with the boron?
Well, no. All right, so the boron is placed at the very center where all this northern polarity and southern polarity magnets, like I say, on a different spectrum, you don't see it, but they all beam into a center point. And when you put boron there, all of the toroidal twisting motions of these magnets create power, usable power, with no moving parts. Yeah, sounds amazing. I know, but it's true. And I'll put the primer fusion videos in here for you guys to see. Thank you. I'll be right back, though.
I'd kind of like a device like that, but I'd have to move in an apartment first. I'm not gonna have a device like that just in my one room.
Okay, so I've got the link copied. I'm going to drop it in the link, the live stream text one, and I've already put in there the 3 primer field videos. Now this is primer fusion videos. It'll be the top 3. You'll see it'll say primer fusion 1, 2, and 3. And do what you will with it. It's pretty cool. I'll drop it in there now.
Dude. Whoa.
Yeah, I could only imagine making one of these magnetic Bowl arrays, like 4 or 5 foot in diameter, and then having some really strong neodymium magnets in there or electromagnets, and just crank it up and see what we can destroy, kind of thing, or create. But, yeah.
Dude, this is basically like a cold fusion generator. This is pretty impressive.
You're on the right trail. Yeah. Yeah, I would say if everyone got brave and just bucked the system, and everyone built their own, I mean, 1 million worldwide. I mean, you think they would really spend all the funds and money to chase everyone down, and take their machine? I don't know, possibly, but I think that would be an uprising.
But dude, you
Don't
wouldn't
take
even
our free
need to
energy
do that.
machine.
You could just literally build like a relatively big one, like under a gas-powered power plant, and just like have it running, and then like I don't know, not use as much gas, and then couldn't be traced. Like you could build these things really easily.
Yeah, and you know how we have the the gas wells. I mean, you could probably just bore down in the ground and just let that, like you said, just let it naturally flow up into a big machine, and boron is very easy to get, very cheap to get. But yeah, I think it'd be something. I mean, this is fairly new too. Even the primer field theory is like 2018 or 19, and this guy came up with it all by itself. So I've been trying to spread the word about plasma physics and primer fields. Even the primer fields are concentric from the strong. These bowls also create the strong force, and concentric circles going outward from the center. Even magnetic and non-magnetic metals will align to these fields that these bowls create, which is crazy to think about, but yeah, it happens.
It's crazy that it's as simple as just basically aligning a bunch of magnets, and it just does that. That is crazy.
Yeah, there's a lot of things happening that we can tap into. We just don't see or feel until it's amplified. And one other thing. So I don't believe in a globe or the way they present the universe. I do believe in a closed vacuum firmament. Like everything in here is, at a certain level in height and depth is simple to understand. But what I'm saying is, when you look up in the heavens and you see these, whether they be holographic or not, in a lab, you can use these bowls and create these, I want to say explosions or tears in the fabric or medium, background medium. And these nebula, the nebula that forms, or the spin of what they call galaxies or whatever, it's all plasma based and can be shown to happen with these bowls. And it's a miracle.
Then it's a side effect. It's rather a side effect of plasma being like a holographic side effect then.
Yeah. I mean, that's a good way to put it. Yeah. Mm-hmm.
But then it isn't plasma what you're seeing. You're seeing a holographic side effect that just happens within it.
Well, when you think of gas that's been ionized, I mean, that could be a different way of saying it instead of plasma. It's been shocked, like. Mm-hmm.
It's not like
but I'll leave y'all with that.
It's not like a light bulb effect because that's local. It's not like the whole thing
Sure.
lights up. It's a holographic side effect that you then see that within it.
Okay.
It's not.
I need to study a little bit more up on holograms. I know they're fractal in nature, but yeah, man, feel free to drop anything, DM me, or something you think could benefit from. I appreciate it. But I'm gonna leave y'all with it, man. I got a few things I need to do.
Very new for me. I think I saw
check into it
one time before, but it just kind of like didn't have room in my head for it. But this is fascinating indeed.
Mm-hmm. Yes, sir. All right, buddy. Well, y'all have a good one, man. God bless, and take care.
Yeah, thanks. Thanks for the lead.
No problem.